So next move on to the next segment, where we will talk about how we evaluate object detection algorithm. And so if your algorithm is saying for this particular image, like these all are people, then I mean, it's fine. Visually, we can say, okay, it's kind of doing a good job. It's missing some of the individuals, and some of these are like wrongly predicted. For example, this is not a person, right? We are missing on this, we are missing on this. But so we need a number, okay, a number between 0 and 1, which says that how good this algorithm is. And that's how we'll be able to compare, like if we have multiple algorithms. Otherwise, just looking at this image, it's very hard. Okay, so we'll get that number, and let's discuss like how exactly we can get that number. So before that, let's do a quick recap of intersection over union. We saw that earlier. Okay, so you will have two different bounding boxes. A yellow one is the intersection, which will go in the numerator, right? And the blue one is the union, which is like all the area these two bounding boxes are covering. And we just compute a ratio of these two. Now, again, we need like, so the threshold which we talked earlier, so there is a distinction. That threshold was for NMS algorithm. Okay, so the idea is you have your, so that was part of the algorithm. That was not part of your evaluation. Okay, so evaluation will start when you say that, okay, this is the model, these are the predictions. Then evaluation will start. And now we are talking about evaluation. But that NMS was part of your algorithm. All right. So that's like a clear difference. Now you have these detections. Now let's see like how the number looks like when the intersection over union score changes. In this case, you can select high overlap. You will get something like 0.9. And in this case, this is like something which I was saying. Even the score is 0.5. It doesn't mean like it's completely half overlap. Right? It's much bigger than that. But still you have a score of 0.5. And this is like 0.3. And it's going down. No overlap. You will get a score of 0. Okay. So this threshold over here is for evaluation. And usually you say that, okay, if you have set the threshold of 0.5 for evaluation, then what you will do is you will have the ground truth. Let's say this red box, and this purple box is, let's say, your network's prediction. You will compute IOU, and this prediction is only correct. Two scenarios. Your class label should be correct. So your algorithm should be able to say, okay, purple box is actually a car, and you will compute this IOU, and then you will say that, okay, this IOU score is actually greater than 0.5. Okay, so that's the threshold. And this threshold we are going to use when we do the evaluation. Okay, so let's try to understand few terms before we go through the exact algorithm. The first thing is true positives, which means that, let's say the red bounding box is the ground truth, and yellow one is like what your networks predicted. Okay, so in this case, first of all, as I said, the class label should be correct. Network is saying this this yellow bounding box is a bird, and the ground truth bounding box is also a bird, and the intersection over union of these two is greater than some threshold, let's say 0.5. Then this prediction is a true positive. And then there, of course, will be a lot of false positives. And again, there are a lot of variations there. Your intersection over union might be clearing the threshold, it's greater than 0.5, but then the model is saying it's a cat. Okay, so that's a false positive. Again, your network might be saying this bounding box is a bird, but the intersection over union is actually less than 0.5. Again, that's a false positive. And if there is no overlap at all, of course, that's a false positive. Okay. Now, the other category is false negative. And the idea here is you had like some kind of bounding box in your image, but your network was not able to see this image or this object. And it says, okay, no bird is present. It's not predicting any bounding box at all. So that's called false negative, because your network is saying nothing is present, but in fact, a bird was actually present there. And you can relate like these terms with, I think earlier when we were talking about recall, it's exactly the same idea.